Hello everyone, this is a presentation of a project which is a tic-tac-toe game using the MinMax algorithm. I'm here with my teammates Anvesh and Nandan. So we'll be discussing about the tic-tac-toe game, the objectives of the tic-tac-toe and the overview and the various algorithms where we can represent the tic-tac-toe game, and we are using the MinMax algorithm. So we'll be briefly discussing about what we are actually doing in this MinMax algorithm, and later on we'll be going ahead to look into the overview of the algorithm and how the code is working. So so basically I'll be explaining you what is a tic-tac-toe game. So it is a 9 grid game which will be playing between the two players. So here we'll be playing with against the computer, which is considered as the artificial intelligence. So which makes the optimal moves to while you're playing the game. So the game is considered between the two players, and the winner is decided by having the same sign in vertically, horizontally, or diagonally. So if a person is can either choose as a symbol X or O, and if a person is choosing the symbol X and he's having the same symbol all around the horizontal way and the vertical way or the diagonal way, what do you call the ascending diagonal or the descending diagonal, then he's considered as the winner. So there are various algorithms to represent this game. Some of them are the reinforcement learning, and some of them are the MinMax algorithm. So we are using the MinMax algorithm in this project. So so MinMax algorithm, what it basically does is it finds the optimal solution to defeat the other player and to win the game. So what I mean by the optimal solution is it actually checks for each and every possible scenario way, and it considers the best scenario, so that which will have the maximum ways to win the game. So so in this game, we are using the MinMax algorithm, but we also found some of the best algorithms where we can implement this game, such as the reinforcement learning, where the main objectives of this using this algorithm are the environment rewards and the goal rewards. Uh, but we actually selected the MinMax algorithm. The reason why we specifically chose the MinMax algorithm is because we found that this algorithm is actually finding each and every possible way to, the possible way or the optimal solution to win the game. So so we will be discussing what we actually doing in this MinMax algorithm, and rest of the part will be explained by my friend.
Hi, this is Anvesh. I'll be explaining the min-max algorithm in detail. So it is basically like a professional chess player. This algorithm sees a few steps ahead and puts itself in the shoes of its opponents. So it keeps playing ahead until it reaches a terminal arrangement of the board, that is the terminal state, resulting in whether it a tie, a win, or a loss. Once in a terminal state, the AI will assign an arbitrary positions, that is the arbitrary position like a plus 10 points for a win, or a negative score, that is minus 10 points if it's a loss, or a neutral score for a tie. At the same time, the algorithm evaluates the moves that leads to a terminal state based on the player's turn. So for example, it will choose the move with maximum score when it is the AI's turn, and choose the move with minimum score when it is the human player's turn. So using this strategy, Minimax avoids losing to the human player. So as shown in the PPT, a Minimax algorithm can be best defined as a recursive function that does the following things. So returning a plus 10 points when it is a win state. If it's a draw, it returns a 0, or if it predicts it's going to lose, it's gonna return minus 10. And it's gonna go through all the available spots on the board after a player chooses his decision. So so it evaluates each values from the recursive function and returns the best value. So in min-max algorithm, it has mainly two utility values, mainly the min and max value. That is the main key part of the AI agent to decide its next optimal move. For this case, the agent prioritizes moves with a maximum value of 10 and opts for a minimum value of -10. Again, Minimax assumes that its opponent plays optimally, that the opponent is trying to win and not trying to lose. So here the min value is the value that agent seeks to minimize the possible loss for a worst case scenario. For every horizontal vertical diagonal lane on the board position, a negative value is decreased, and then for every additional opponent move on a lane you have negative -1. And for the max value, the AI seeks to maximize the possible gain for a best case scenario, and then for every additional move you made on the lane you have +1 gain. However, if there are two of your moves, your max value becomes +10. That's the key part in this algorithm. As you can observe, if you observe the diagram over here, you can see when an user enters when a user I mean when the player clicks on a button, that is if he chooses his move, the algorithm calculates his predicts his next moves by giving all the possible scenarios, like what are the best cases and worst case scenarios on level 2, that is. And from those levels the algorithm's gonna continue and gonna predict all the other moves which is on the level 5, 6, 7 and 8. And from that it's continue, and the recursion process is continued until it reaches that optimal solution, that is 10. So from that based on the user's input, it's gonna choose the best optimal solutions from those.
Just now, my friend Anvesh and Surya explained about the algorithms which I have used in this project. Right now, and I'm gonna explain the framework which we have used. There's two frameworks comparing each other. One is a brute force flow, and the other one is alpha beta flow. The brute force flow algorithm refers to the programming methods that does not include any tricks to improve the performance, and but depends instead on brute computational power to try out all options until a problem is solved. But the most optimized thing is the alpha beta flow. The alpha beta min max algorithm is used to cut the branches of the tree which won't contribute positively to the goal state, and that needs to be arrived at. Alpha beta pruning allows the space to be used in the compact manner as well as use of efficiency. And the main purpose of this tic-tac-toe is to win the multiple games as well as efficient use of the system.
Like my friends said, we can do it in brute force also, and also alpha beta flow. But since brute force tries out all the options until an optimal solution is reached, it is not optimal, it is not an best way to do it. But we can use alpha beta pruning, that is it eliminates all the possible paths based on a goal state. Like if we reach an condition, it does not gonna go forward with all other options, because we know that the rest of the options are not going to be optimal. So it is the main so it's gonna drastically reduce the computational power needed for the algorithm to run. And the performance analysis for the brute force solutions gonna be the uh, n into the equation is given here in the ppt. This involves applying the marker at a randomly available square on the 3 into 3 grid. So the chances of winning are 80%, but it has a higher space complexity. So we can tell that because after when we analyze the code, There are two for loops which add an n complexity each respectively. For each loop nested within an n, it is multiplied by the outer loop. So for each if and else statement, the time complexity is gonna be the constant because it is 1. We can reduce the time complexity of brute force to n 2n into 10. That so in if we normalize the equation, that's gonna be n square, which is not optimal. So in alpha beta pruning, we gonna prune all the rest of the options which are not optimal. So in this, that although time complexity seems to be low in time when compared to the optimal winning strategies achieved, it is rendered useless. The algorithm is required to be not only efficient but also accurate. So the improvised alpha beta pruning algorithm for tic-tac-toe game, understanding that winning strategies begin with taking the corners. Our algorithm is set such that we take up the ends. So when if we reduce if we cut down the state space by pruning and eliminating all other options, we can reduce the time complexity by big O of bm, which is way less than big O of n square, which is around 80% less than the brute force solutions, and we can reduce the computational power on our algorithm. So this is the code which we're gonna do. So we have done it using a JavaScript and a basic HTML, and we have implemented separate we have modularized the code using different JavaScript files. That is board.js, which is gonna implement which is gonna have the board logic for constructing the graphic, the layout. And the cell files gonna have the uh, you mean so the cell JavaScript files contain all the logic required for the user to click the cells and populate the winning criteria. And this files contains all the logic which contains when the necessary conditions are met, and also how to populate a cell with respect to character, like that is x or whether it is a o. And the main logic for the minmax algorithms gonna be in the sketch.js file. So here the function play is starting of the game, and compute mu is the recursive function in this QUM, which is like a heart of the algorithm. It is a recursive function. So in line 141, it's gonna call the function recursively until the necessary conditions are met. So when each and every for every each and every recursive call, it's gonna check on line 122, it's gonna check whether after user clicks on the cell, it's gonna check whether it's a winnable move or not a lose, it is a lost one. And based on that, if it's a win, it's gonna return -10. This is the minimum min criteria which is written by the minmax algorithm. Or if it's a loss, if it's a draw, it's gonna return the 0, like here. And if it's a draw, if it's a win, it's gonna return 10. If it's a loss, it's gonna return -10, which is explained in by Suya. And also for each and every recursive call, this function is called is board filled, because we have to check whether the board is filled or not. And also we have to the get state method is also gets called, because we have to get the state at a particular moment when user clicks on that cell. So this is the win check function, which is called to check the winning state of the game. And if we run this program in the index.html, so this is the game. So as you can see, after I am playing the player as X, so the AI is chose 0, and I'm clicking it here and here. So as you can see, when I won, it's showing as 0 as 1 because I was not able to win this game. Yeah, the AI clearly won. So this is the tic-tac-toe game which we have implemented using the MiniMax algorithm.